So the mass of A that will keep the system from moving, and then the mass of A that'll allow the system to move at a constant velocity. First, let's draw exactly what's going on here. We have a mass A connected to a frictionless pulley, and we have a mass B connected to the string. Let's draw free body diagrams for both of these. So we can do the second mass first, just because it's a little bit easier. So mass of B, here going up is such a force tension, and going down we just have a force of gravity. So that'll be it for that mass. And then mass of A, here we have force normal, and then we have the force of gravity, so m sub a g, and then here we have force tension. And to the back, in the direction opposite of motion, we have force of friction. So for part A, we can say that mass of B, G, equals force of tension. And that's simply looking at the free body diagram for the second mass. And we know that the force of tension must equal the force of friction. And that's just looking at the free body diagram for the first mass. And we know that this must be less than mu sub s mag in order for this not to move. So mass of A should be greater than or equal to mass of B divided by the coefficient of static friction. This should equal 2 divided by 0.4, and this will equal 5 kilograms. So the mass of A should be greater than or equal to 5.0 kilograms in order for the system to not move whatsoever. And then for part B, we're saying that mu k equals 0.20. However, we need this system to move with a constant velocity. So here, again, acceleration is still 0. So we can say that the mass of A simply equals the mass of B divided by mu sub k. And this should equal 2 divided by 0.2, and this should equal 10 kilograms. So the mass of A must equal 10 kilograms in order for the system to move at a constant velocity. However, the mass of A should can be for part A, the mass of A should be greater than or equal to 5 kilograms in order to prevent the system from moving in the first place. This is only after the mass starts moving. So you would need to maybe increase the mass of the second mass of B, in order to start it moving, and then if the mass of A were to be exactly equal to 10 kilograms, then at that point would it continue at a constant velocity. But again, part A, mass of A must be greater than or equal to 5 kilograms, and then for part B, the mass of A must be equal to 10 kilograms. That is the end of the solution. Thank you for watching.